Yeah, so this is pretty gross. Got a lot of clutter. When I say gross, think about that. I don't know what that is. Oh man, look at all this. I gotta clean that to work on the robot. That's some willpower stuff, man. Look at all that. I'll do like a time lapse. Be like therapy, cleaning it. Problem is like space and also organization. Like I don't have one. Ooh, alright. Willpower. Music. This is so funny. I've been looking for my ESP01 flasher forever. Like I even made my own with this serial programmer thing, but the ESP would go on there. That's literally it was in this box. You see? Like why? Why did I put it in there? A freaking LiDAR sensor box. Oh, and an empty reel tape thing. Oh, slow cleaning, sorting. So here are the parts I ordered. These things are smaller than I imagined. Damn. That's what she said. I also read that they only spin like 100 RPMs. So, I mean, it makes sense with all the gearing, but that'll be interesting. This is probably the H bridge. Jizz. Let me get my hand free. Also, they're that big. I'll have to figure out how to wire these up. Get the power to actually feed it. Here's this one in comparison, way bigger. This is what I was saying where this thing sticks out on both sides. This might be what I end up going with just because this robot is way bigger than I was thinking about. Just because of all the joints. Like, I normally use these MG90D Metal D servos. Metal servos. Those are like too small. You'll need more torque to move the entire arm. So yeah, this design will adapt or change over time. Alright, so here's the Pi. I'm gonna look up how to connect this to the motor, to the Pi, and power. Then I'll write some code to run it. And eventually, once the wheels are designed, I'll calibrate it like... Wow, this thing feels mad cheap. But you can't complain, right? They're like $2. Yeah, I'll say like move 1 inch or 1/4 inch or whatever. And also, when the robot's fully like designed, the middle will have an IMU so I can, you know, estimate position. But look at this guy. How am I supposed to work? This is gonna record that. It's cool. This thing can drive 2 motors. So I bought like, I don't know, 4 of them or something. But yeah, this one will drive both motors. So one thing to note is I'm not trying to like spend a lot of money on this project. I'm trying to use like whatever I have already. I'm not to buy like that driver board, but like battery wise, normally I'd use like an 18650, but I don't know, I could buy more, I guess. The other thing is I'm trying to get the parts here soon. Like my break starts the 23rd, so that's when I would want to have the parts on hand. But I don't know. Can't remember how many of these cells I bought. Like, here's one right here. These are really nice. Bottom, like Panasonic or something. The problem with those is they're protected cells, so they're longer than usual. They don't fit in the like containers. I also have like these really heavy NiCad batteries, but I don't want the robot to be heavy because the servos are going to be holding it up. So I'll probably just use these like drone batteries, or I have these cells which unfortunately got puffy even just sitting there. I mean, I discharged them for storage, but yeah, they got puffy for some reason. Discharge them for storage, yeah. So I don't know. Just working through it. This guy's just in the way, man. How am I gonna solder? First thing I'm gonna do right now is solder these headers on. It's gonna be sticking out to the bottom. Get out of the way. Oh, don't bite that. And I'll put it on the breadboard, connect the Pi to it, connect it to the motor, and then I'll just use the benchtop power supply here. I'm thinking, well, I don't know, see, it could be like 5 volts, but these servos, I don't know. You can run servos directly through a LiPo battery, but it has to have the right voltage, you know. But I was thinking about current draw limitations through these like boost converter things, you know. Although if you're using 2 cells, you would step down. Yeah, the problem is they have like a limit, like 2 amps or something, and I don't know. I'm gonna have these like beefy servos, and that's what I was concerned about, how much current they're gonna pull. I'll have to like use this where you can set the voltage and watch the dynamic current. Oh man, that's a tight fit. This tripod. It's kind of exciting. I haven't made anything in a while. I took all the tools off this table, so I'm like, I need something. I'll just try not to burn myself here. This is a good soldering. What do you call this stuff? Solder? I'm soldering it upside down because I can see the pinout labels. You could do it upside down, but what I've done is I've got a flux on this like Q-tip. I drag it on the back right over the holes, and then that helps it stick. Just like that, and it gives you a nice, that cone shaped solder. This is a really awkward position to solder, just so I can film it. You are able to just touch it, and because of the flux it sticks automatically. Every time I solder, I just think, Tony Stark built this in a cave with a box of scraps. Guys, I'm sorry, I'm not Tony Stark. I am but a mortal. Damn, that's one thing that sucks, is if you don't align it right, it's freaking crooked. Or not 90 degrees. Look at this thing. Pathetic! Alright, so that's one side. Ah, damn, that sucks. My bad. I have to try and like straighten that. Or let me see. It does go on a breadboard still, but yeah, I guess it's not a big deal. It still works. Let's make sure the other side is aligned. FBI! My neighbor's knocking. Alright. Still in focus. I got it on 1.8. Let's get that nice blur. That should be good. The rest of it is just breadboard work. So I'll stick this on here. Ow, damn his hat. There. Did force that down, but should be good. So there we go, we got it on a breadboard. So one thing I want to point out is I've never used this thing before, so I don't know what I'm doing. So it's like you have to find a guide online like this one that shows you how to plug things in. I have a general idea what to do, like what I want it to do, but right now I'm just getting it to work. After that, I can turn it into like a function that you call with code, like turn this on and it'll turn on. But yeah, so right now I'm just doing a discovery, which you do it on a breadboard like this, but then once you understand like how it's connected, then you actually put it on one of these and solder it so it doesn't come apart. The professional way is to design a solder board, but I can't do that yet either. So I think at this point I've got it fully wired. We've got a power and ground going to this motor, which I don't know if it's ground, it's just like a direction. But then this benchtop power supply here will power the motor. I just have like clips going into the board. There's a shared ground with the Pi. I think that's all you need. And then the other 4 wires, apparently 2 of them are direction and then the other 2 are PWM for speed, which I have some vague idea what that is, but I've never actually written the duty cycle or whatever it is. So we're gonna find some sample code and assimilate that into our code base for this project. Alright, so we got some AI generated code here. Well, Google sourced it from some website anyway. I had to update the wiring because I actually had wired it for 2 motors, but right now I'm just running 1. What's interesting is this PWM pin, which controls the speed supposedly. The power supply is on, so I'm gonna try and run this code. See what happens. It is not moving. Alright, that is a fail. Now let's find out why. I didn't notice this, but when it's powered on, it has a red light underneath, so that's helpful. Alright, so I got it working. One of the things I had to do is not share ground between the 2 things, which is weird. Normally you do, but maybe that's only for communication or something. But yeah, so if I hit enter on the shell here, it'll go. And it's pretty fast too for a robot. It's drawing 140 milliamps. Yeah, that's cool. Here's the thing here. This is from Google Code. I don't know why it's hard to find a tutorial with just a regular Raspberry Pi. Most tutorials are a Pico. That's good, I can work with that.